What?
He tried to give me a math problem that doesn't think I can solve. If you do 24x plus infinity x squared, would it be infinity x cubed? Because
No.
it's like terms. 24x and infinity x are both.
But if one is squared and one is cubed, they're not like terms.
No, the answer. One's only x, and then.
Okay, guys, listen to me.
Please.
Listen to me.
Please just say yes to prove my point.
You're totally right, and I'm so proud of you.
Thank you.
I'm so proud of you. Okay, now cover your ears for a second. She's crazy. She's an absolute crazy person. All right, now you can both be happy, and we're good, right? Yeah?
That's right.
He gave it back to me? Oh,
He misheard you.
no, wait.
He misheard you.
You can't just say I misheard you.
No, because I didn't say one of the things weren't cubed, but the answer was cubed.
I know, but when you add, you can't change the exponent on something. Like x squared plus x squared isn't x to the fourth, it's 2x squared.
So
It have to be like terms.
Unless you're
Also, what are we doing right now? Also, infinity isn't a number.
Thank you.
That's a much broader. You're just gonna have to be Ava. Ava, just change the name, okay? I gotta print a new one for Ava. Oh, this is a disaster. It's a disaster. Okay, shh. Guys, listen. I gotta be honest. Listening to you talk right now is making me feel pretty much exactly like that. So we're gonna stop. All right? That is what I feel like in this moment. I feel like Festerto. So we're gonna get to it. No. Oh, for goodness sakes, I gave you a science test. Okay, where's No, you're not just doing the retest. Where's the math tests? Oh, I'm drowning.
take your science tomorrow.
Okay, you can take the retest because I don't know where your test is. Why do I not know where your test? Oh, because I'm an idiot. That's why. Oh, that's okay.
Where are the rest?
There's actually a question with an easy answer. Quiet, you. Okay, let's take a look.
No, it might be in there.
I know. Okay. No.
No, the tests are right here.
It's fine. I know, but not her. Just simmer down. It's probably in my mailbox or something. I haven't been to my mailbox in weeks. So, if we wanted to add this, just remember, okay? When you're adding fractions, right? If we said like, I have a quarter of a pizza and you have 2 quarters of a pizza, how many quarters of a pizza do we have altogether? 3. Okay, what changed there? A quarter plus 2 quarters equals 3 quarters. Okay, good. What changed there? Like just visually looking at it. Yeah, the numerator changed. What didn't change? The denominator. That's important, right? That's an understanding what fractions actually are. It's what proportion of something, and when you're adding them, the numerator changes because we're changing how much of that thing we have, but the denominator doesn't change because when you're adding and subtracting fractions, the denominator is just telling you what it is you're adding and subtracting.
What if the denominator is different?
If they're different, you can't add them together because they're not like terms.
So you have to make them.
Right? Does that make sense? So, look at me. You can only add like terms, and in fractions, the term we use for that is we say we're finding a common denominator. But what we mean is that the denominators have to be the same for them to be like terms. And then once the denominators are the same, the denominator is what makes them a like term. The part we are adding is the top, which we call the numerator. Good, okay. So, with that in mind, can we add these two things together as they are written here?
No.
As they're written here, these are not like terms because we're not saying x makes them like terms here. For these to be like terms, the whole denominator would have to be the same. Is the denominator exactly the same in these cases? No. This is saying we have 1 out of 5x things, and this is saying we have 2 out of 2x things. Those are different denominators. These are not like terms. So to add them, we have to make them like terms. What can you do to change a fraction as it appears without changing the value of the fraction?
Increase or decrease both.
Yep, and you have to do it not by adding or subtracting, but by multiplying or dividing. Right, yeah. But in this case, we're going to multiply. What could we make the common denominator for these? What could I make it so that the two denominators would be the same?
You could multiply each equation.
And I mean, we could make it 5x by multiplying this by 2.5, but we don't want to do that. You know, we don't want to work with decimals. We want to work with nice whole numbers.
Isn't that where you find where they can both so it'd be like 10?
Yep, beautiful. Exactly right.
Do they have to be multiplied by the same?
Nope. Well, top and bottom do, but not the two. So we could multiply this one by 2. Good. And that would give us what as the new version of that fraction? 2 over 10x, which is the same thing as 1 over 5x, right? Equivalent expressions. What can we multiply this by so that it will share the same denominator of 10x? We can multiply it by 5. Good. All right. And now our new expression would be 2 over 10x plus 10 over 10x. Okay. And now we can do that math. What do we get when we do that math? Very good. 12 over 10x. Right? What is it pointedly not? It is not 12 over 20x, right? That's not how fractions work, right? These make them like terms. These make them common denominators. And now that's a good answer, but it's not getting me on the Christmas card list, that's for sure. What do we have to do to make that Christmas card worthy? We have to simplify. And what can we simplify here? Yep, very good. We can divide both top and bottom by 2, and that will yield us what? 6 over 5x. Very good. Excuse me. So 1 over 5x plus 2 over 2x is 6 over 5x, right? Fractions aren't super intuitive, right? Maybe that's intuitive to you. That's not intuitive to me. How's that feel? Feel okay? Okay. You try one. Try this one out.
You're missing a y.
Yeah.
It's 2y over 3x squared plus x over 2xy.
Oh, okay. Jeez, what is going on with OneNote right now? That's weird. Does that now look like yours?
Yes.
Jeez Louise. Very strange. Very strange. Unhappy. Don't
I'm holding
approve.
your paper clips hostage.
Oh, wait.
So you need to find a common denominator. Give this a crack. See what you can do.
If it's squared, do we have to make it cubed?
Not necessarily if you want to make it cubed. But there's no reason to make this cubed. But what we do need to do is make this x also squared, right? Yeah. So don't make it cubed. That's just going to make, you could, but there's no reason to. But you do need to make this one match that one. What is our common denominator going to be? Just out of curiosity. And my advice would be that'll be the number. What about the variables? So the number on both one will be 6. Will there have to be x's in both of them? Okay, x or x squared?
X squared.
Okay. Will they both have to have y's? Yeah. Can we get away with just y though?
Yes.
Yeah. So see what you can do with that. All right? Give it a shot. Do your best. So I want to show you kind of what my internal monologue is, or what my thought process is Does that make sense? Back to what Autumn was asking about earlier, like sort of how do you think about this stuff in a way where you're not just kind of blindly doing it? To find a common denominator, everything has to be common. The number, but also the variables. Does that make sense? And I deal with each one at a time because I'm not smart enough to deal with them all at the same time. Does that make sense? So if I'm looking at these two fractions, first I'd say, well, the number on the bottom of this one is 3, and the number on the bottom of that one is 2. And if the numbers are 3 and 2, what's the common denominator going to be? 6. Okay. Then I want to look at each variable. And again, I don't look at them all together. I look at them one at a time. I say, okay, I've got x's, right? So I look and I say, okay, the first one has x squared, right? The second one only has x. Well, you can't make the x's go away, but it's easy to make more of them show up. You just multiply by x, right? So where does x squared and x meet as a common denominator? Well, we're just going to make them both x squared. That's easy, right? And then the first one doesn't have a y. It's blank. There's nothing there. But the second one does have a y. So what do we have to do for a common denominator there? Add a y. And so altogether, what does my common denominator end up being? 6x squared y. Guys, I kind of feel like I don't have everyone's attention, but it's pretty important that we get this so we can move on. Because this is grade 9 work. What we have to do after this is turn it into grade 11 work. So make sure you're with me, please. So we end up with 6x squared y as what's going to be our common denominator. Now, 3x squared, what are we going to have to multiply that by to make it into 6x squared y? What are we going to have to multiply to make the 3 turn into a 6? 2. Do we have to multiply anything to make the x squared turn into x squared? Nope. Do we have to multiply by anything to make the blank turn into a y? Yeah, we're going to have to multiply it by y. So we have to multiply the bottom of that by 2 and by y, by 2y. And whatever we multiply the bottom by, we got to multiply the top by. Okay, so what does that end up with as a fraction? The bottom will be 6x squared y. That's what we're trying to make it. What will the top be? Yeah, 2 times 2 is 4. Y times y is y squared. Very good. Okay, now, again, the second fraction, we have to turn into 6x squared y on the bottom. Right now, it's 2xy. What do we have to multiply 2 by to turn it into 6? 3. What do we have to multiply x by to turn it into x squared? Okay. And what do we have to multiply y by to turn it into y? Nope. If we multiply it by y, what would that turn it into? It turned into y squared. So we don't want to do that. What do we have to multiply it by to turn it into y? Yeah, nothing, right? We don't want to change it. So we don't multiply it by anything. So what are we going to multiply the bottom of this by? 3x. And if I multiply the bottom of the fraction by 3x, I got to multiply the top by 3x. And so we end up with 3x squared. Very good. Now, what will the simplified version of this be? Well, we just do numerator plus numerator. And that's going to give us that. And we're going to have, I'm going to put them in alphabetical order. That's the good manners of it. I'm going to put 3x squared plus 4y squared. It doesn't actually matter, but the usual manners is we put them in alphabetical order. And that's the answer. You cannot simplify that. Yes?
Do you have to put it like that, or can you do 7x squared y squared?
No, you can't do that because you can only add like terms. Listen, if you have 3 apples and I have 4 oranges, do we have 7 apple oranges?
Yeah.
And of course we don't, right? Like there's no such thing as an apple orange. If there is, I'd eat it. But yeah. Yeah, go nuts. Hola. Yeah, remember, you can only add like terms. So if the terms aren't alike, you can't put them together. They have to stay separate. And listen, I get it. We want things to be compact, right? So we see 3x squared plus 4y. We want to be like, oh, great, 7. 3 plus 4 is 7. But again, if you have 3 cats and I have 4 children, we don't have 7 cat children.
Yeah, we do.
That doesn't make any sense. That doesn't mean anything. Right? It's an important premise.
If we have unicorns, we have cat children.
Okay, now, to be clear, this is a review of grade 9 math.
What?
Yeah, a little ugly, but there it is. Ready to take it to grade 11?
No.
Who's ready? This guy. Who else? That guy.
No.
Who else? That girl. We're ready. Team, look at me. We got this.
I'm gonna hide under
Let's
this
just
so I
be...
don't point.
Do you feel like this right now? A little bit? Little bit? Wide-eyed? Skinny-legged?
Did you put the copyright license? Is that copyright license?
It is Creative Commons licensed. Yeah, listen, I follow my own rules. I should have cited it. I didn't cite it. Anyway, okay, look here. Yeah, you should have, Orlando. I'm sorry. Seth, I'm sorry. Stop beating me. Anyway, see in the recording, it's going to sound like he came up and hit me. Seth, stop. Oh, God, stop. I'm sorry. Check's in the mail.
Orlando's just clapping his hands.
Okay,
He's not
anyway,
actually getting beat.
there we go.
Sounds more
Anyway,
abuse.
where was I? Okay, now, look here. This is a little ugly, right? Can we all agree this is a little ugly?
Yeah.
A little bit ugly, a little bit scary. Who's a little scared right now? It's okay, you can own it. It is a little scary, but here's what I want you to notice. Do these have the same denominator? No. Okay. So, just like above, all we can do is multiply it by something, right? Well, we're not going to get fancy here. When in doubt, all we're going to do is just going to say, okay, this, I'm just going to multiply this side by x minus 3, and then this side will also have an x minus 3. And then all I'm going to do is take x plus 2 and multiply it by that side, and then this side will also have an x plus 2. Which, if you stop and think about it, is actually really easy. Okay? So we're not going to get fancy here. We're not going to try to think what's the lowest possible common denominator. We're just going to make a common denominator, because we're going to take this and multiply it over there. We're going to take that and multiply it over here. So work with me. We're going to go slow, but you got to stick with me. All right? We're going to say, okay, the denominator down here right now is x minus 3, right? What I'm going to do is I'm going to multiply it by x plus 2 as well. When I do that, what will be the new denominator? Well, the new denominator will be x plus 2 times x minus 3. But of course, if I multiply the bottom by that, what do I have to do at the top? Multiply it by x plus 2. Good. So what will the numerator of this be? We will eventually expand it. No, don't shut your mouth. We're actually going to do exactly what you just said. We are going to expand it, but not yet. So now we're just going to leave it there. What will the right side of this be? Well, hold up. What do we need to do to the bottom here? It already has an x plus 2 on the bottom. To make it the same denominator as the other side, what do I need to multiply it by? Good. Does that make sense? We're just going to take the other one, and we're going to put it here. But now if I do that to the bottom, I also have to do it to the top. What will the numerator of this be now then?
X minus 3 and x minus 7.
Yep, exactly right. Very good.
Does it matter the order?
It does not matter what order you put it in. Okay, now, okay, now, this can just be written as a single fraction, right? We know that x plus 2 times x minus 3 is now the common denominator. And of course, we're just going to add the two numerators together. But it's in factored form, and you can't add things together. You can't collect like terms when they're in factored form. So what do we have to do with both of these? We have to expand them. We have to put them out. Yeah. So let's look at this one. And this is where, remember we said, like, just expanding these is such an important skill. To be able to do it just in your head. Remind me, when you have a binomial like this, when you expand it, what's the first term going to be?
X squared.
X squared. How do we get the second term? The second term will be something x. How do we get it?
You add
No.
numbers.
You add them, right? Think when you're factoring, the middle term you get by adding them together, 7x. And what will the last term be?
Then multiplied together.
That's where you multiply them and you get 10.
So we add them and then multiply them?
That's right. So making sure that we can do that expansion, back to that idea that you don't want to be driving the car having to think about where your hands go. Because then you're not going to remember where the Taco Bell is. And that, my friends, is a travesty because then you don't get to your Taco Bell. And I love me my Taco Bell.
I also love Taco Bell.
Oh, I love some Taco Bell.
Ew.
Oh, yeah. Listen, sometimes you want a good taco, and sometimes you want Taco Bell. They're different.
They are very different.
They're different, but it's good. Anyway, we're going to focus in. We're going to focus in because you know me, guys. Focused. Yeah. Yep. Yeah, guys, so look here. Like, like to get to here? Yeah. Yep, that's the right side. That's what we get here. Yep, that's exactly what we did. Like, I switched the order from you, maybe, but that's the same. The order doesn't matter. So if you have x minus 3 times x minus 7, that's just as good. Yeah, that's right. The order doesn't matter. If you swap them, that's totally okay. There isn't even really a rule about it. It's just random. That was a good question, by the way. So now, what about this? What's that going to turn into up here? Well, again, how do we get the first term? The first term is x squared. What will the second term be?
It would be 10x.
Yeah, and make sure it's negative. And then what will the last term be? Be careful.
Positive 21.
+21.
Yeah, and be careful. And positive or negative?
Positive.
Very good. All right, I'm terribly sorry, guys, but I'm going to.
He's on his phone.
Yeah, I gotta. You're gonna be okay with that, or you're not. But All right. So there we go. Now, you do not need to expand the bottom. You can. It would not be wrong to expand the bottom. But I think once something is nicely factored, there's no good reason to expand it unless, like this wasn't nicely factored up here because we had two things nicely factored. We want to combine them, right? This bottom, leave it alone. All right? Now we can collect like terms. So the bottom can stay the same, x plus 2 times x minus 3, and let's collect like terms at the top. Does x squared have a like term?
Yeah.
It is?
2.
For a total of?
2x squared.
2x squared. Good. Right? X squared plus x squared. Good. Does plus 7x have a like term?
Yeah.
What is it?
Negative 10x.
Okay, which gives us what?
Negative 3x.
Okay, negative 3x. And finally, we know that positive 10 has a like term. 21. And that would give us plus 31. Will that factor? Maybe. We could check to see if that factors. There's no common factor, right? They can't all be divided by 2. They can't all be divided by x. We could check to see if anything is divisible by 62, right? I honestly don't know. It can't possibly be because this is positive, so both numbers would have to be negative. And there's no two negative numbers that will add to negative 3, add to negative 3 that multiply to 62, right? It's too small. So this won't factor. This top does not factor. You could test it and try it. But this doesn't factor. So that means that this is our final answer. Yeah. Well, the reason we'd factor it is potentially if we factored it, what might end up happening? You could end up with an x plus 2 or an x minus 3 and they could cancel. You could, but there's no reason to do that. If it doesn't factor, like you could, and it wouldn't be wrong, don't waste your time. If it doesn't factor nicely, leave it alone. Okay, how's that? A little brutal? What if, hear me out, What if I made it worse? How would we feel about that?
Let's not.
What if I was like, hey guys, this could be worse? How would we feel about that?
Like
It's not much worse. It's look at me, it's a little worse. I just got an eyebrow raise. I got a saucy eyebrow raise. Just a little. So guys, it's a little bit worse.
This is how I feel.
Yes?
Right here.
Will graphs be involved?
No.
Okay, then I'm good.
Good. No. Good old algebra.
This is how I would.
Okay, the only difference here is that if you look at the bottom, this is in expanded form. So it's just like the last question. It's just like the last. Guys, look at me. It's just like the last question, except what do we have to do with this first? We gotta factor it.
We're not done with factoring? Oh wait, we said it's not going away and you should never forget it? This is why. You didn't take all the scissors, did you?
I don't think I borrowed the scissors. Why are they using scissors?
The mosaics that we haven't.
Oh yeah.
Oh yeah, I gotta do that.
Yeah, get that to me by tomorrow.
Oh, by tomorrow?
No.
We'll say Monday. You can have till Monday. Do you want till Monday? Yeah, you can have till Monday. That's fine.
Oh,
Okay, so now listen. This is all set up, but what do we have to do with this? Factor. Now this is a nice easy one. Nice easy one, right? Can we all agree a nice easy one?
Yeah.
Because we need two numbers that multiply to 2, which are obviously just 2 and 1. And does that work for the middle term?
Yeah.
Yep. So what is this in factored form? Now, hey guys, what do we notice? We can cancel.
Yeah.
All right. So that's nice, right? That felt insincere, but I'm still going to take it. What would be on the top of this now?
1.
Yeah, 1. The default in multiplying and dividing is 1, right? When you divide things by themselves, you get 1. And what's left on the bottom here? X plus 1. And then over here, what do we have? X minus 5. And now what do we have to do? Can we add these together yet?
No.
No, we have to find common denominator. What am I going to multiply the bottom here by so that they'll be common? Nope. X plus 1. And of course, if I multiply the bottom by that, I also have to multiply the top. And what am I going to multiply this side by so that the denominators are common? X minus 5. Okay. Not so bad, right? And so what do we end up with? I'm going to do it as a single fraction. What's on the bottom now?
X plus 1, X minus 5.
X plus 1 and X minus 5. And then now that 1 will be replaced by what? 1 times X minus 5 is just X minus 5. And this 1 times X plus 1 will just be replaced with X plus 1.
So wait, this whole thing equals 1.
And then, of course, what goes between them? Plus, because we're adding, right? That's what we were doing with the fractions.
No.
And now we can collect like terms. Does X have a like term? X. What's X plus X?
2X.
No.
2X.
Yeah, listen. If you have a dog and I have a dog, we definitely don't have a dog squared. I don't even know what that means. But probably it means they're like mating or something, and I don't want to think about that. No, if you have a dog and I have a dog, together we have 2 dogs, right? Okay, so there we go. So that would be 2x is what that simplifies to. And does negative 5 have a like term? Yeah, plus 1. What's negative 5 plus 1?
4.
Negative 4. Good. And that's our final answer. The top can be factored, but just very simply. What do we notice about the top? What can it be factored by? That's right. We can divide that by 2. Not a very exciting one, but you never know. It might end up canceling with something below. Spoiler alert, in this case, it doesn't. The top can be divided by 2, which would leave us with what in the bracket? 2x divided by 2 is x, and negative 4 divided by 2 is negative 2, right? That would be our final version of that. Yeah. Yo. Say it again.
It's like we show 1 as x usually, but like we didn't change 1 to x, so it's actually just a 1 this time.
Yeah, when you divide it, like 1, we should never be turning 1 into x. Sometimes we have 1x, right? But no, the number 1 is the number 1. And if you divide anything by itself, anytime we cancel, what you're left with is 1, because anything divided by itself is actually the number 1. That's not like a placeholder or something. It really is the number 1. Did that answer your question? Cool. Okay, these can be clumsy. True or false? This is a lot trickier than the multiplying one, right? Much worse. Fractions can be tricky to work with when you're adding or subtracting. This is why we like to factor things and work with multiplication, right? Adding and subtracting of fractions, clumsy stuff. You got to be careful. Easy to make mistakes. You know what makes it a lot easier to make a mistake? Subtraction makes it easy to make mistakes. But listen, we got this. Here's a nice simple one. Are the denominators common right now? No, they look similar, but they're not the same. And listen, my first mental trick is I always immediately throw a bracket around it like that. Does that make sense? So I'm thinking of them in factored form. Does that make sense? That little mental trick helps me avoid making a lot of mistakes. What do I need to multiply the left side by to get these to be common? What has to go here?
-1.
Yeah, to make them match, this one needs an x plus 6. And to make them match, what does this one need? Good. And if we do that on the bottom, we also have to do the same on the top. Which means, what's our next line look like? The bottom of this would be x plus 6, x minus 6. And the second one would be x plus 6, x minus 6. And what is the top of this one? What's x plus 6 times 1? Well, 1 times x is just x, and 1 times 6 is just 6. Okay. And what's x minus 6 times 1? Well, 1 times x is just, and 1 times -6 is just -6. Okay, now, this is where we need to be careful. We're going to put them on, I'm actually going to work, well, I guess I've been working sideways. I'm going to keep working sideways. We'll put them with a common denominator now. X plus 6, x minus 6. But now listen, this is what you have to remember. So easy to make this mistake. Obviously, the first term is just x plus 6, right? But now when we're subtracting this whole thing. Does that make sense? You got to watch out for that. That means we're not adding x, we are subtracting x. Okay, that one's obvious, right? But now this is where it gets a little scary. So negative x means subtract x. That's easy, right? What does it mean to subtract -6? Taking away -6, and if you're taking away -6, the better way to write that is
Add 6.
plus 6. You got to watch for that. So listen, the way I always remember it, when you're subtracting a multi-term like this, it just switches all the signs. Does that make sense? Like we were at it, this was x minus 6, so actually the x is negative, we're subtracting x, and if the 6 had been negative, now it's going to be positive. When you're subtracting, the thing you're subtracting, all of the signs switch on you. All right? And listen, that's going to be your number one mistake. Everyone makes that mistake. I make that mistake. Everyone makes that mistake. It's just so easy. But you got to try to watch out for it. And it's a real case of like a thing I spend a lot of time doing with high school math students, especially the clever ones, is being like, just slow down. Because it's easy to go too fast and miss that. You know what I mean? And it's a case where being clever can kind of work against you. Because you're like, oh, I know what I'm doing. Boom, 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 boom. And then you miss details. So sometimes when you're clever, you got to actually make sure that you're slowing down, taking your time, and making sure you don't miss details. Does that make sense? How's that feel? Now to actually collect the like terms, What will the denominator still be, of course? X plus 6, x minus 6. And now, does x have a denominator? Does x have a like term? What is it? Minus x. What's x minus x? Nothing. Do I even need to write that? No. I mean, I would if that was the only thing here, but then we also have 6. Does it have a like term? What is it?
6.
Which gives us what? 12. So the final answer is 12 over x plus 6, x minus 6. If you wanted to expand the bottom of this, could you? Yeah, but we like it in factored form. If you wanted to, again, there's nothing wrong with it. We should be able to expand that very quickly. What do we notice that is? That's one of our special cases. Difference of squares, right? So what will that simplify to? We square both of them, right? X squared and 36. And what goes between them? Negative side, right? So if you prefer it in expanded form, you can do that. Doesn't matter. That's factored form. If the question doesn't ask you, you can leave it in either. And if the question doesn't ask you, you probably don't want to do extra math. You probably just want to leave it in factored form. If you really love doing extra math, you can put it in expanded form. That's totally up to you. Is that okay? How we doing? This is a brain-bendy lesson, all right? This one's definitely going to take some practice. Definitely going to take some working on it to make sure we got it, because it's things we find scary, right? There's factoring, there's finding a common denominator, there's subtracting whole sets of terms, lots of places to make mistakes. But that's what we're here for. All right. We ready for an ugly one?
No.
This one, let's look. This one's ugly, right? Straight up. Sorry.
Why
It's an equation only a mother could love. But here we go. We're going to take a look at it.
I don't think a mother could love this one.
Okay. We're going to leave the tops totally alone for now. What do we have to do with the bottoms if we're going to find a common denominator first? We have to factor them. Okay. Can we factor this? We need two numbers that multiply to negative 48. What are those going to be? Negative 6 times positive 8. I like that because when we add those together, we get 2. All right? This is where having strong times tables helps, right? If you don't, practice some times tables. Doesn't hurt to get that cemented. But we could print out a sheet for you of factors. If you've ever seen those charts of factors up to, that can be helpful. But negative 6 times 8, yeah, that's good. So what would I put as the factored form down here? Yeah, and does it make any difference if somebody else chose to do x plus 8, x minus 6? Nah, same thing. Okay, good job. What about this feller here? We need two numbers that multiply to 30 and add to negative 1.
Negative 6 and 5.
Very good. Negative 6 times positive 5. Again, if that's a little bit slower for you, that's okay. You'll be fine. Though if you can do that quickly, you're less likely to kind of lose your spot. What goes on the bottom here?
X minus 6, x plus 5.
Okay. Now, did we get lucky like last time and do any of our terms cancel with what's above them?
No.
Nope, no such luck, team. But there is something kind of lucky. What do we notice? Yeah. Okay, we're already part way to a common denominator. Do we see that? Not every question will work that way. We got a little lucky here. They at least already have x minus 6 in common. Now the problem is, this last one, what doesn't it have that the first one does? Okay, so we can just multiply the bottom by x plus 8. But then, of course, what do I have to do at the top? I also have to put x plus 8 there. What doesn't this one have that the last one does? Okay, but if I do that to the bottom, I also have to do it to the top. Okay, now, for the moment, I'm going to do this as two separate fractions. Then we'll combine them after. X plus 5, x minus 6, x plus 8. Again, the order doesn't matter, but I am going to put them in the same order just so I notice that they are common. You don't have to put them in the same order, but I like that as a heuristic. This top, can we jump right to it expanded? Is that okay? X plus 5 times x plus 9. We know we're going to have to expand it, right? Can we do that? What is x plus 5 times x plus 9? X squared plus 14x plus, what's 5 times 9? 45. All right? So I'm going to get rid of those highlighting because whatever. And instead I'm going to say that is equal to that, right? For the moment. Okay. What about this? What will we get here? What's x minus 9 times x plus 8? Yep. Yep. Negative x. Yep. Not 62. 72. Good. That's okay. Okay, but now when we go to combine these, I actually find it easier not to write them out on the same line. I find it easier to go, yep. Okay, yeah, no worries, that's okay. So can we look at this? We have x minus x squared. What's that going to give us?
0.
No x squareds. Does that make sense?
No x squared.
Okay. We could write that just as a placeholder if we want. I'm going to erase it after because we don't actually have that, right? But just so I don't kind of lose my spot. Okay, what about 14x? Now let's be careful here. Minus negative x. Well, if we are subtracting a negative, we are adding. So what's 14 plus x?
15x.
So 14x and we get another x. We have 15x. Okay. And then finally, we have 45 minus negative 72. Okay, well, when we're subtracting a negative, we're actually adding. Is it 117? Yeah. Okay. And then, of course, do I want to write 0x squared? No. So I would say over x plus 5, x minus 6, x plus 8. On the top, we would have 15x plus 117. And that's our final answer. That's a little bit nasty, right? Can we all agree? Yeah. Yeah, listen, this stuff is tricky. It really is tricky. You will have to get practicing to make sure you don't get lost in it. Yes? Sorry? Yes. So that is, you don't have to do that, but that's a great question. And I think you might actually find this helpful. So everyone pay attention because I really like the question. You will notice that every time I do this, I always write the denominators first. That is to remind myself that when we're working with fractions and adding and subtracting, the denominators don't change. The only time they ever change is when we multiply, i.e. when I'm finding a common denominator, I intentionally change the denominators. I multiply the top and bottom by something. Otherwise, the denominators are never going to change because when we add or subtract fractions, a quarter plus 2 quarters isn't 3/8, it's 3/4. The denominator doesn't change. So one of my heuristics, one of my things that I do the same every time is I always write the denominators first because I'm mentally saying to myself, we're talking about this as the denominator. That's not going to change. All I have to think about is the top. And in addition to that being just a habit, it actually makes the question less stressful because as busy as this looks, right, none of this is involved in our math. Do you know what I mean? Like, all of that jazz is just going to stay the same now for the rest of the question. It's done. It's over. So really, the part of this that I'm actually doing is all that stuff minus all this stuff. And that's not so bad, right? Like, that's less stressful. So I probably should have mentioned that, actually, that, yeah, I always write the denominator first, and I always kind of, in my mind, am saying, that's locked in. I know what that is. Now I've got to deal with the numerator. Because on these questions, it's the numerator that you're going to have to work with. And we, of course, should check to see if that factors, but 115 and 117, maybe 3. Is 117 divisible by 3? I don't think so. But maybe. Can we check it? Oh, it would be, actually. It is. So actually, what do we get as our, if we divide that by 3? So we would get 3 and then 5x plus 39. Okay. So that is really, I guess, the real you get invited to Calford's Christmas party kind of answer.
What if I didn't want to go in the first place? Because I'd rather stay at home.
Okay. Like, I think he'll be all right. I think his party will still go on. You're good. Okay. One more. It's more of the same. All right? It's more of the same. Just want to make sure we got this. So again, to show you my heuristic, to show you kind of my pattern that I follow, I throw brackets around these so I'm not going to accidentally start adding or doing something crazy. And then I note that what am I going to have to do with that? Yep. And this one, what am I going to do? Yeah. All right? And before I can do that, I don't want to multiply by these two crazy things. What am I going to do with both sets? Factor, factor, factor. When in doubt, what do we do? Factor, factor, factor. When in doubt, we factor. So, in this case, same with that heuristic, I'm going to write the tops down first, because right now I know I'm leaving them alone. Whenever I'm leaving something alone, it's the first thing I write, so I don't accidentally get silly and change it. What is this bottom going to factor to? This is a nice, easy one again. We need two numbers that multiply to 2 and add to 3. 2 and 1. X plus 2, x plus 1. This other one down here is numbers that multiply to 7 and add to 8. Very good. So x plus 7, x plus 1. Now, the nice thing is, just like in the last question.
Excuse me, interruption.
Yep.
Can you please check your attendance?
Yep.
Responsible
It's on
adult.
the film.
Cuss word, cuss word. I'm thinking of a cuss word. Anyway, where was I? So, what do we have to multiply this left fraction by so it'll have the same denominator as the right one? This one needs an x plus 7. And what does this one need? X plus 2. Great. So we're going to do that right now. Who's not here? That's not my attendance. That's my roster. I don't need a roster. Adam's here. Evan's not here. Is everyone else here? I think everyone else is here. We're going yes. Okay. So, now, this side is missing that x plus 7. So we're just going to put it there. But of course, if I do it to the bottom, I also have to do it to the top. Okay. And this side is missing x plus 2. And of course, if I put it at the bottom, I also have to put it at the top. Okay. Now, the bottom of this thing is now going to be easy. X plus 7, x plus 2, x plus 1. But we've got to work with this. This is a nice, easy one. What's x times x? X squared. What's x times 7? Okay. That one's pretty easy. This one, a little bit nastier. What's 3x times x? Okay, and I'm putting the negative sign, and I'm going to put a big bracket here, so I remember that I'm subtracting all of this. Is that cool? Okay, so 3x times x is 3x squared. What's 3x times 2? Okay, and let's keep going. What's negative 2 times x? Very good. And then what's negative 2 times 2?
Negative 4.
Not x, right? Just negative 4. Okay, now here, I would rewrite this as a second line. As annoying as it is, because it takes time, because I want to deal with that, the fact that we're subtracting all that. Does everyone get why I did this? Put it in the square brackets. It's because I have to subtract all of that, right? We're subtracting. So now I would write this again, x squared plus 7x. But now, the fact that we're subtracting all of this is going to switch all of the signs, right? So we're subtracting 3x squared. We're subtracting, which would be negative 6x. Now, we're subtracting negative 2x. So that's going to be positive 2x. And we are subtracting negative 4, which means that's going to be positive 4. So we just got to remember that when we subtract a whole set of terms, all of the signs are going to switch, right? And that's so easy to forget. It's the most common error. It's probably the error you're going to make most commonly at first, and then you're going to get great at it. Yep.
So you, since there's two numbers on top, that's why you gave them like plus times over times one everything.
Yep.
And that's the only way you're gonna do that is if there's two numbers on top for the first value.
I mean, you can do that every time. These ones we can just do by eyeballing, right? We've got lots of practice. These ones you probably aren't going to eyeball. If you can eyeball it, great. And now let's collect our like terms. Does x squared have a like term? What is it? Negative 3x squared. What's that total? You had an x squared. Somebody took 3 away from you. Now you've got
Negative 2.
negative 2x squared. It's good. Does 7x have a like term?
Yeah.
Yeah, what is it?
Negative 6x and 2x.
Okay, good. So you have 7 x's. Somebody takes 6 of them away, but then they give you 2 more x's. What do you have?
3x.
7 minus 6 is 1. 1 plus 2 is 3. And finally, 4. Does it have a like term? No, it's all by itself. So we'll just write it. And there we go. Nasty little question. Yeah? Nasty little question. But very doable. All right? You're going to need practice with this. Look at me. You're going to need practice with this, yes? Do your homework. All right? I'm here to help. Please come for help if this is stressing you out. But step 1, try the questions. Try and struggle with it a bit, all right? You got to practice. This will not come to you by osmosis. You won't learn this by just hanging out near, who's really good at Calford?